it might be common to think, okay, it's easy to take a derivative of a single term, but what happens if the function is made up of several terms? You know, instead of being 3x squared, it's 3x squared minus 10, or something like that. How do we deal with that? And the answer is that it works pretty much exactly the way you would expect. If I have two functions, f and g, and they're both differentiable, then the derivative of the sum of the terms is the sum of the derivatives. Or the difference of the terms is the difference of the derivatives. Or the difference of the functions is the difference of the derivatives. What does that mean? Well, what it means is something like this. If I have this function minus this function plus that function, so we have that sort of those added functions, we take their derivatives separately and then add them together. So pretty simple. X cubed, its derivative is 3x squared by the power rule. Negative 4x, its derivative is negative 4 by the power rule. And the derivative of 5 is 0 by the constant rule. So we just take each derivative piece by piece. Next, what we have is something that looks very similar. And we take the derivative by the power rule, we bring the 4 down, cancels with the 2 to leave, and there's a negative here, to leave a negative 2, x to the third. We bring the 3 down, 9, we subtract 1 from the value to have x squared. We have an x, so it falls off, we have negative 2. So all those are that constant multiple rule of the power rule. Now finally we have this piece. Now this is a quotient. So you might ask yourself, how do I deal with a quotient? And what we're going to find is we actually have a couple of different techniques that you can do to apply quotients. But in this particular case, we're going to break this up so that we can use the power rule. So if we break this up into 3 separate fractions, 3x squared over x minus x over x plus 1 over x. So you just break that up. Then what you're going to have is the x's are going to cancel here. You're going to have 3x minus 1 plus 1 over x, which might better be written as 3x minus 1 plus x to the negative 1. So if we then use the power rule here, again the x drops off, leaving us a 3. This is a constant, so its derivative is 0. And then we bring 1 down, bring the negative 1 down, and then subtract 1 from it. So we end up with 3 minus x to the negative 2, which we rewrite as 1 over x squared. But we could recombine them back into this. And we want to do that because this is kind of a preview of another method we're going to use, and it'll show you how you could get the same result using a different differentiation method.